Hello class, welcome to Unit 6, Lesson 1. We're going to go ahead and learn about vectors today. Your learning targets is that you can add and subtract vectors. You should also be able to multiply a vector by a constant, find the magnitude of a vector, and then find the horizontal and vertical components of a vector. So we're going to be learning lots of things about vectors. So in order to do that, we should probably know what a vector is. A vector is a line segment with a magnitude and direction. Magnitude is just the length, and we all know what direction is. It's telling you which way to go. So vector tells you which way to go and for how long to go in that direction. This should be u. So vector u is equal to from A to B. So A is our starting point, and I can see that in this notation here because we have A and then we have the arrow going to B. So B then is our terminal point. So vectors, we have a starting point and we have an ending point. And then once again, magnitude is the length of the segment. So when I refer to magnitude, it's how long is it from A to B. So today we're going to learn how to add and subtract vectors. So if I have vector u plus vector v, and I'm telling you vector u is the same as from A to B, okay, what you would do is you would say, well, I'm going to go from A to B. And then I would add on vector v, which in this case is from B to C. So I would go from A to B, plus then I would go from B to C. That's our vector v. And my addition would result in the distance, the new distance, in between from A to B and then from B to C. So this right here is really u plus v, this dashed line right here. So that's what the addition of vectors would look like. Now let's look at subtraction. Now we're going to take vector u and we're going to subtract vector v. So we have our picture of our vector u plus our vector v. Well, if I'm going to do u minus v this time, I'm still going to go to u, and then I'm going to go the opposite direction of v. So v is going currently like northeast. Now we're going to go the opposite direction. We're going to go this way. And we're going to go, whoops, that's not perfect, but nice little line here. And we're going to go the same distance. So if I could do this perfectly, it'd be the same distance. So this is our negative vector v. So u minus v would look like this. And when you find the subtraction, what you're really doing is finding this dashed line right here. So this is vector u minus vector v. Okay, so that's what it looks like visually. Some other things that we need to talk about is the components of a vector. Okay, a vector, what it really is it will look like an ordered pair, but what it's telling us is we go A direction horizontally and B direction vertically. Well, let's think about this. Horizontally is this way, which makes sense because do you guys remember this is our x-axis, which we would list first typically in ordered pairs, and vertically y. So we usually think about ordered pairs as x comma y. So it's the same idea with vectors, but instead of using x and y, of course, we're going to now use a and b. So a is our horizontal distance and b is our vertical distance. So what vector v would look like is, let's say, we're going to draw it out. We have initial point P. So we're starting out at point P, and we are going to point Q. So this is point P. We're going to point Q. We are saying that vector v goes from P to Q. Another way you might see it is we have our horizontal distance of A. So this distance would be our distance of A, and this would be our distance of B. So it can tell you to get to point Q, we might go horizontally this many units and then up vertically this many units. Okay. We can think about this also, vectors, in terms of ordered pairs. If I have, let's say this is x1, y1, and this is x2, y2. If I wanted to find my distance for A, all I would have to do is take my x2 value minus my x1 value. So that's what we're talking about here. And then vertically, we would take our y2 minus our y1. That's what they're talking about here. So if I ask you to find a vector from an initial point to a terminal, you can just take your x values, subtract them, and your y values and subtract them. The last thing we need to talk about is magnitude. Magnitude is, oh, right there it is listed, the length of a vector. Okay, so if I want to find the length of a vector, first of all, the notation is kind of these two brackets or two bars like this. This is our magnitude, which means the length. So from P to Q, I'm just going to show that on here. This would be the magnitude from P to Q would be from here to here. And the way you find that is it's a form of the distance formula. And so all you have to do is take your x value, square it, plus your y value, square it, and then take the square root. You guys remember the distance formula? X2 minus x1 squared plus y2 minus y1 squared. The square root of all that. And what is A? A is x2 minus x1. So it's a form of the distance formula. So there's magnitude. Okay. Lots of things going on. Let's just talk about algebraically how we will do this. I just want you to bear with me when we get to a real example. It will help clear up things and we can come back and relook at this if needed. So when we're adding vectors, if I have vector u and vector v, if I want to add vector u and vector v, all you have to do is take and add your x values or your a values. And same thing with b, just take your b values and add them together. Same thing goes with subtracting. If I want to subtract, you just take your a values and you subtract, you take and subtract your a values. Then you get your new value. And if I have my b values, you just go ahead and subtract those. And then lastly, we have our scalar multiplication, or just multiplying by a constant. So if I want to take a constant times our vector, you just multiply each value times that constant. So let's go ahead and look at an example of that. So I'm going to go 2 slides ahead, and then we're going to come on back. So we're going to skip this for right now. We're going to look right here. So example 1, we have vector u and vector v, and I want to add them. Well, if I want to add them, I'm just going to list it out. My vector u is 3, 6, plus my vector v is negative 4, 1. And in order to add them, I have to take the values, my a values, and just add them together. So it's really 3 plus a negative 4, comma, 6 plus 1, my b values, which gives me negative 1, 7. So that is my new vector after there is u plus v being added. Okay. Let's look at b. b is multiplying by our constant. Really what it is we have 3 times vector u. Well, vector u is 3, 6. And what do we have to do? We just have to multiply each one by 3. So my new vector is 3 times 3, 9, and 3 times 6, 18. So there is my multiplication by a constant. Okay. Then I get to problem C. It is 4 times vector u plus 2 times vector v. Do you guys remember good old PEMDAS, order of operations? Okay, we don't have parentheses or exponents, but we do have multiplying and we have addition. So we must do the multiplication first, then we would add them together. So I have to multiply u by 4 and then 2 by v, and then I can add the vectors. So let's go ahead and I'm just going to write this out. So we have 4 times our u, which is 3, 6, plus 2 times our v, which is negative 4, 1. So I'm actually going to do the multiplication now. So we got 4 times 3 is 12, 4 times 6 is 24, plus 2 times negative 4, negative 8, and 2 times 1 is 2. Now that I have done the multiplication, now I can go ahead and add them. So I would do 12 plus a negative 8, which gives me 4. And then 24 plus 2 gives me 26. So there is 4u plus 2v. Okay. And lastly, problem D. This notation is the magnitude. And the equation for magnitude is equal to the square root of a squared plus b squared. So it wants it for vector u, so I do not need to use anything from v, I just need to use values from u. So it is the square root of parentheses 3 squared plus parentheses 6 squared. Not a big deal because both the numbers are positive, but if I was doing v, I'd want to do parentheses negative 4 squared because it should be a positive 16. And here I would have 3 squared is 9 plus 6 squared is 36. So 9 plus 36 is 45. So we have the square root of 45. and I want everything always simplified all the way. I do know there's a perfect square in 45, 9 times 5. So we have square root of 9 times 5, and the square root of 9 is 3, square root of 5. So that would be my magnitude for vector u. Okay. So those are our operations with adding, subtracting, and finding the magnitude, and also multiplying by a constant. So those are kind of like our first 4 learning targets, or sorry, first 3 learning targets. Yep, now we're going to move on to our last learning target, and it's that you can find the horizontal and vertical components of a vector. So I'm going to go ahead and move back to this slide. So the horizontal and vertical components of a vector, okay? Vector v is a vector with magnitude v and a direction of theta. Okay, so most of our vectors have a direction of theta. Sometimes it will also be direction, could be an angle. So this is an angle. Could be an angle. It could be, or it could be a quadrant number. I could tell you what quadrant we're in. Okay, or I could tell you southwest, southeast, northwest, or northeast, any of those things. So when I talk about direction, it could be any of those. It could be a theta, which is an angle, and then you'd figure out where that angle is. Or it could be a quadrant. Just to remind you, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I did that wrong. Whoop. There we go. Quadrant 4. And then in order to have like north, south, east, west, those kind of things, we would go north, and then this direction is east, so northeast. Then it would be from northwest, is in west, is in this quadrant. Then this would be south, and towards this way would be southeast, and then this would be southwest. So direction could be, once again, an angle, a quadrant, or directions in terms of a compass. Okay. The components of a vector. Okay. Sometimes it's written in a form AI plus BJ. So if I have 5I plus 7j, what it's really saying is I could write the vector as 5, 7. This is just another way to write vector form. So what we need to do is sometimes I will ask you to find the ordered pair. Okay, so far we've always been given the ordered pair, but sometimes I might ask you to find it. And so the way you can find it is actually using trig, which makes sense because you're in a trig class. So let's just take a look here. If I have, just going to draw here to here. If I have this vector, okay, and I am trying to find A and B, I really need to figure out, well, what is this A and what is this B? Okay, well, we know that from here to here, what do we call this? I should put an arrow because it's going this direction. The length of my vector, that's called my magnitude. Okay, so if I tell you the magnitude and I tell you this angle here, could you figure out A and B if you know the actual numbers of these things? Yes, you could. You need to use basic trig. And by basic trig, I mean our pal SOHCAHTOA. Okay, so if I have this angle, I know B is my opposite, and then my hypotenuse is my magnitude, and then this is my adjacent. So the way that you could find, if let's just start with A, because it's the first thing, is I would have my hypotenuse and I have my adjacent. That would be cosine. So I'd have cosine of theta is equal to A over my magnitude of V. And if I do a little work to actually solve for A, I would times both sides by the magnitude. So A is equal to the magnitude of V cosine of theta. If you notice, that's what we have written right there. Okay, so they're telling us that's how you could find the value of A. Then the value of B. Well, I have my hypotenuse, and I need to find my opposite. So once again, who uses opposite and hypotenuse? Sine does. So sine of theta is equal to B over the magnitude of V. And if I multiply both sides by the magnitude of vector V, I will have the magnitude of vector V times sine of theta. Then I would be able to find these numbers and write out what A and B are. Okay. So lots going on this slide, but let's look at an example that can help us make sense of this. Okay, so if we turn to example 2, so we did this example 1 already, let's do example 2. Here is what they give us. They tell us theta. They tell us it is a 45-degree angle, and we are in quadrant 2, so there's our direction. We're in quadrant 2, and we have a magnitude of 70, okay? So I'm going to go ahead, draw myself a little XY coordinate plane here, and I have a theta of 48 degrees. So what this means is from here, my x-axis, up to my vector, this is 48 degrees. I'm in quadrant 2, so I'm here. And then they tell me my magnitude is 70. Okay, well, that's the distance here. So what I need to do is I need to find A, which is my horizontal distance, so from here to here, and I need to find my B. So let's just start out by finding A. Once again, if I label my sides, you don't even have to memorize the things we talked about. I know that this is my opposite, and this is my hypotenuse, and this is my adjacent. So how am I going to find A? I have my adjacent and my hypotenuse. So it is cosine of 48 degrees is equal to A over 70. So A is going to equal, times both sides by 70, 70 cosine of 48 degrees. So let's go ahead and type that in on our calculator. Biggest thing I need you to remember, 48 degrees, so it needs to be in degrees. So I would type in 70 cosine. Oh, I better make sure I'm in degrees. Go to your mode, make sure you're in degrees. I'm in degrees, or you could look up here, I guess. 70 cosine of 48. Yep, 48. And I get 46.839. Okay, so there is, rounded to 3 decimal places, my A value. 46.839. So there's A. Now I just need to go ahead and find B. The way I find B is I have my opposite and my hypotenuse. So I would, for opposite and hypotenuse, that's sine. So I have sine of 48 is equal to B over 70. So once again, B is equal to 70 sine of 48 degrees. Once again, we stay in degree mode, and I type it in my calculator, and you get 52.020. And now I need to find my actual vector, the ordered pair vector form. So what it is A. But we always think about it still in terms of x and y. So if I'm going to the left, do you guys agree this is a negative direction? So my A should not be positive. It's really negative 46.839. And my B, we're going up, so that should stay positive, 52.020. So there is my ordered pair for example 2. Okay. Questions on example 2? Just let me know and write them down. Otherwise, let's look at example 3. Same idea. It does not tell me the quadrant, but we can figure it out based on the theta that they give us. So they tell me 150 degrees. So I know that this line right here is 180 degrees, so I'm going all the way over to here. That's 150. That means that my vector, once again, is in quadrant 2, and it has a magnitude of 120. Okay, so I'm going to draw in A and B. So A is my horizontal, so here's A, and here's B. And in order to solve this, I need an angle inside the triangle. So I do 180 minus 150, which gives us a 30-degree angle. And now let's solve for A. In order to find A, it's going to be cosine again. But if you're not sure, you would just label everything. This is my opposite. This is my hypotenuse. This is my adjacent. So to find A, we have our adjacent and our hypotenuse. So we have cosine 30 degrees is equal to A over 120. So A is equal to 120 cosine of 30. Type it into your calculator and you get 103.923. Then I go ahead and let's solve for B. Opposite and hypotenuse, so that's sine 30 degrees. Is equal to B over 120. So B is equal to, times both sides by 120. 120 sine of 30. If you type it into your calculator, and as long as I did it before correctly, you should get an answer of 60. Then my final answer, we put our A and B together. Once again, we are in quadrant 2, so my horizontal is a negative. So it should be negative 103.923, and my B should be 60. There is my vector going up, positive. Okay. So that is how you find components, okay, if you're given the angle and the magnitude. And then the last thing we want to do is just find vector xy for the given, or for which the given statement is true. So basically we have addition of two vectors, and when I add the two vectors, I get a result of -2, 8. Well, that's pretty easy. How do we add? We just take who's in the same spot and add them together, and they're going to equal -2. So we have 3 plus x is equal to -2. So let's just solve for x. So I would subtract 3, so x is equal to -5. And then I would do the same thing for my y's. 5 plus y equals 8. And I would subtract 5, so y is equal to 3. And then I just go ahead and my vector xy is -5, 3. Okay, so that's what you would have to have added to 3, 5 in order to get -2, 8. All right, so your learning targets, you should be able to add and subtract vectors. Multiply them by a constant, find the magnitude, and that's a formula you're going to need to know. So remember, magnitude square root of a squared plus b squared. And then find the vertical and horizontal components. So that's like our example 2 and 3. So we have to use sine and cosine. So that is it for our notes. Your homework is the Unit 6 Lesson 1 Vectors worksheet. So please make sure that is completed by our next class period. And I will talk to you later. Have a great day.